Okay, so finding a derivative at this point is a royal pain in the neck. This week, probably because of our shortened schedule, we'll have to wait till Thursday, but we'll start doing that process very quickly. And we'll learn a bunch of rules. Remember I told you have about 20 rules that you'll have to learn and know by memory, but we'll do a lot of them. We'll do enough to where it becomes pretty much second nature. Some of them you'll have to just study to keep memorized because we won't use them as much. But for now, taking a derivative is finding the limit as, remember, our x gap approaches 0. So bringing 2 points together on a curve to bring a secant slope to a tangent slope, or at least as close as we can. And because doing that creates a 0 denominator and numerator, it creates an indeterminate form. We have to take the limit in order to get around that. Okay? So just a quick review of the concept. I guess I'll write the definition first. So this is what we're plugging into, just our definition of derivative. In fact, I should have written f prime of x out here, out to the side. Sorry about that. Okay. And then we just plug in, like for x, we plug in x plus h in the first term, and then the second term it's just x. So I have this work done here. This was a little bit of an issue on the test, the ones that had the radical. So as soon as you fill in x plus h, you realize, well, actually even before that, you kind of realize that this is indeterminate. So we have to rationalize and simplify. Yeah.
There should be a thing for the h on the third, right?
Where?
Yeah, there should be a 3 on the third one down.
Yeah, there should. Right there.
And then everything after
That looks like 31.
that. 31.
There we go. So how did rationalizing go today? What?
How would you cancel out the h's if it's 3h?
Oh, you're right.
The h's still cancel and just leaves the 3 there.
But what if you had like 2h plus h, then you would cancel the 2h's, but you leave the 2h? Does that make sense?
Let me write what you said. If you had 2h plus h
Over h.
over h.
Then you would just cross off the h's and leave the 2h, right?
No. You can't do that. If you had this, first of all, you'd want to combine your like terms, right? 2h plus h. But even if you didn't, like if let's say you didn't see that, these h's would cancel, but also those h's would cancel. Yeah. Okay. So just take a look at the work. If you need me to talk through it, I'm happy to do that, but this will save us a little bit of time. Any questions on it? Other questions, I should say? So your derivative, 3 over, I kind of lost my fraction there, so let me stick that back in there. 3 over 2 root 3x. Yes?
Yeah. And do we write that with the dx over dy?
Yep. Or f prime, either one. If you're gonna, but let me clarify. If you're gonna use Leibniz notation, this needs to be df dx, not dy, because the function wasn't defined as y. So be careful with that. Function and making sure notation matches is a really important detail that they will ding you for if you mix it up. Okay. So what is this if we kind of zoom out a little and say, what did we just find? I know it said derivative, but what does that even mean? If we maybe say a statement, this is what? Awesome. Okay, if that didn't pop right to your head, you got to go review 2.2 where we defined the derivative, and maybe even 2.1 as well. This is the slope of the tangent line. Where, or of what? Of what? Tangent line of what?
Square root of 3x.
Of f of x, or yes, square root of 3x, at any point. So we could now, if I said, write the equation of the tangent line at x equals 5, what would you do? Just, this is all review of Friday since we had a weekend. If you want to write this, just as practice. So a tangent line at x equals 5. What would we do? All right, well, what does that give us? No, I don't mean the answer. I mean saying, what is, if we plug 5 into that, what does that give us? Description-wise. Okay. So m, let's write our little point slope form. Again, remember you can do, like here you could do f of x, and there just x, and this could be f prime of x or a, any version of this that works for you. I think I told you last week I preferred just the regular one myself. Okay, notice right away that we don't know y1. Did anybody think of that? Yeah. So y1, where do we get y1 from?
F of 5.
Yeah, we need f of 5, which equals root 15. Okay, so that becomes y minus root 15 equals, how do we get m? Trevor? Actually, not somebody else besides Trevor. He already said. Chloe, how about you? How do we get m? Okay, df dx. Okay, I'm going to review notation real quick. Evaluated where? At x equals 5. So remember, to evaluate a derivative in Leibniz notation, we need to put the bar, that vertical line, with x equals. You could also do f prime of 5 if you're using Lagrange notation. So either one. So this is 3 over 2 root 15, since we already plugged 3 or 5 in for the into the radical. Okay, and then x1 is just 5. So there's our equation. It's kind of ugly, but that's our equation of this line. So that's kind of a recap of what we did last week after our test. Any questions on it? Any of the problems we need to look at from homework? You're sure?
Oh, wait, sorry. 13 and 14.
All right, 13 and 14. Okay. Well, here's 14. I happen to have it already on here. So, is that... Secant squared is what? Well, what is secant? 1 over cosine. And cosine of pi over 3? Where is pi over 3? Yeah, so pi over 6, pi over 4, pi over 3. Okay, so cosine of that one is a half, right? So 1 over... I guess I don't know where you're asking, but we're basically doing 1 over 1/2 whole thing squared. Well, 1 over 1/2 is 2, right? So copy dot flip. So this is just 2 squared. There's our 4. And then tangent of pi over 3. Remember, so what is tangent defined as? I'll write it up here so we don't bleed into 13. Sine over cosine. So what's sine of pi over 3?
Root 3 over 2.
Yeah, good job. Root 3 over 2, not root 3 over 3. And then cosine is over 1/2, or excuse me, 1/2. Okay. And then copy dot flip again, and the 2's cancel, and we just get root 3. So that's where the y minus root 3 comes from.
Okay, that makes sense.
So yeah, that was a good unit circle review. Okay, and then 13, is it kind of a similar thing, you think?
Mm-hmm.
Okay. So like cosine of y minus, and then cosine of 2 times pi over 4 becomes cosine of pi over 2, which is 0. And then our slope, negative 2 sine 2 times pi over 4. What is the sine of pi over 2, which is what comes inside? What's sine of pi over 2? Yep. And then multiply by negative 2. So our slope is negative 2, x minus pi over 4. Does that help?
Yeah.
Any other questions on that one? Yeah.
The textbook number is 17.
Okay. All right, so I have this one already written on, but let's talk through it. So the figure below shows the graph of the line tangent to the graph of f at x equals 0. Of the following which must be true. So f prime of 0 equals negative f of 0. So remember, f prime of 0 is the slope of the line at 0. The slope of the tangent line, excuse me. I'll write it. So slope of tangent. Does the slope of the tangent have to equal the function's value there? Or the negative or opposite of the function's value? Is that a must kind of case? No. Okay, obviously B I have circled. Let's talk through C. Again, the slope of the tangent. Does it have to be greater than the value of the function there? No, like it doesn't have to be. It could be, right? Think of it this way. Let's say we have some curve function and maybe there's our point. Let's say that's at 2 or something. Could I have a function where the slope is like 3? Could I have that? Yeah. But does it have to be that? No. Okay. And then in terms of the one we just talked about, it doesn't have to be the opposite of the value either, for sure. Okay, and then obviously D doesn't have to be true. The slope evaluated at that point does not have to be less than either, right? Like my example here shows that it could be greater. So B is the only one that's true. The value of the function there has to be the same, right at that point. Yeah.
I had one for 6B.
You had one, what?
Question.
Oh, did that help at all, Alina? You sure? I'll talk to you later, okay? 6B. 6B, 6B, okay.
6, but just like the second half of it. So
Am I on the right one?
yep.
D is the distance from home when you walk to school. H is the number of hours since 7 a.m. Okay. So what's your question?
With the negative 11, what kind of context should we use? What should we say?
What does D prime mean?
Minus prime.
Interesting. So negative at what does the 0.5 represent?
30 minutes. And so,
Okay. I'm going to say I was walking. What? I would probably in English write it this way, like toward home.
At negative 22 miles per hour.
At 11 miles per hour. Okay, be careful. This is going to come up more later on too, so I'll just introduce it now. I don't know if you heard Judd say at negative. So it depends on what you wrote before that. If I'm walking toward home, that's already addressing the negative, right? My distance is getting less from home. So if I say toward home and then negative, I'm actually walking like away from home again, right? So the sign, it's like when you talked about physics, like the sign of acceleration versus velocity kind of idea, and if those match, and okay. So does that help at all?
Yeah, would it also be right if I said towards school at negative 11 miles per
Towards what?
hour? School.
At
Negative.
yeah, okay, towards school at negative 11. That would be like a double negative. It would be a little bit weird, but it's true. Because that's like saying I'm facing school, but walking backwards.
Yeah,
Is that how you get here?
not usually. I'd probably drive.
Okay. Any others on that? Do you drive backwards?
Oh, maybe.
Any other questions on this one? Okay.
Thank you.
Yeah, sure.
I just didn't know how to address it. Stop.
All right, get your calculators out for this next section. Is it good? Is it good? All right. This one we're basically it's mostly learning how to use the calculator. We probably don't need to talk every time we transition. So, learning how to use the calculator to find derivatives. It's these calculators, actually most calculators can't find a symbolic derivative like what we just did with our warm-up. Here's what I mean, just to review. We found the derivative right here. Your calculator can't give you a symbolic one, like with x still in it. But it can do what we call a like evaluated derivative at a point. It can do that at any point, and it's super fast and it's awesome. It's so nice. Of course, AP is not always just going to ask you to do that. You'll have to do it by hand, but at least you'll have this tool. So estimating the derivative with the calculator, just basically I just need to show you how to find the derivative tool on here. And for me, this, I'll just point. This to me, it doesn't really look like a toolbox, but that's what it is. The symbol there on that button is a toolbox. And so that's where you're going to access a lot of the functions, like on the TI, if you're used to it at all, it was the math button. It's that for this calculator. For some reason, to me, it kind of looks like a printer or something. But anyway, go to the calculation screen and hit that toolbox button. And it's kind of nice because it has a whole category for calculus. So arrow down to that. And I'm going to explain what these first two are. The first one you should recognize as Leibniz notation for taking a derivative and then evaluate it at a point A. The second one with the n up there, remember last week I told you we could take like second derivative, third derivative, etc. That's what that button is for. So if I asked you to take like the fourth derivative of something, that's what you would use. So go ahead and hit OK. In the parentheses, you're just going to enter the function that we're given here in number 1. So sine square root of x. And x, if you forgot, x is right up here where it's x, n, and t. So if you just hit it, it's x. Okay? And then close your parentheses for the square root. And then just arrow over to that orange box. It's kind of just sitting there waiting for you to go tell it where to evaluate. And we're evaluating this one at 2. And then you just hit enter. So that quick, it's telling you not what the derivative of sine root x is, but what the value of it is at x equals 2. It's an estimate, but it does a good job and it's close to the value. So what are we going to write on the paper? It says find f prime of 2. That's what we just did. So what are we going to write down? I mean, are we stuck or are we just not talking today? I can't tell. F prime of 2 equals what?
0.055.
Do we need the 5? Or I mean the 1.
No.
Okay, 0.055 is sufficient. You can add the 1. It doesn't hurt anything. But you don't have to. Hi.
Oh my gosh, wait, what room is this?
322.
And Ocean.
Yeah, what do you need them?
I
Like
just
to
need
go with you?
Just outside with.
Isaac and Ocean. Please? Okay, let's define what this is just to keep reviewing. So 0.055 is what? More specifically, write this down. Slope of the tangent line. Where? To f of x at x equals 2. So it's a slope, right? It's a slope. Slope of a tangent line, not of f, but the tangent line to f. Okay. Go ahead and try number 2, please. Just on your own. Okay. So f prime of 1.3 roughly 0.270. Any issues with that? Okay. Do you like how this one, I just want to point this out because it's one of the things I really like about this computer, this calculator. I love how when you hit divide, you don't have to go put parentheses around the denominator. It's so nice, right? It creates a fraction automatically instead of 16 clicks like on the TI. Okay?
Here on Spider is doing one.
Okay. I must have put that in wrong. Yep. I forgot the natural log. So ignore my answer because I forgot to put the natural log. All right, next one. Write the equation, let's go back there, of the line tangent to y equals this whole thing. Okay, first of all, what should we start with? Are you good? Okay. Chloe, what should we start with? Yeah.
Estimating derivative.
Even before that. Even before that. Let's write down what we're plugging into, right? That way we don't forget. Then both of you guys said good stuff. So Dutch said find the y1 value. Sonia said find the slope or find f prime of 1. And both are good, and it doesn't matter what order you do them in. So which one would you like to do first? All right. I'm going to go with Dutch because I like him better than Trevor.
Oh.
He said find y1. Okay, so square root of 1/2, and we can go ahead and turn that into a decimal, so no big deal with that. So square root of 1/2, and go down, square root of 1/2. What are we going to write? 0.707. Sounds good. And I didn't. 0.707. Okay. Now let's do the slope. Are we going to write dy dx, df dx? What are we going to write? All right. So dy dx. And we want evaluated at x equals 1. Okay. So go ahead and put that in, x over x cubed plus 1. Okay. I forgot my square root. Let me go do that. Sorry, I'm flipping back and forth a lot. Oh, another nice thing is when you enter a menu on here, I don't know if you're noticing, it's staying where I last was, which saves you a little time. It's cool. All right, square root of x over x cubed. What was it? Minus what? Or plus 1. Plus 1 at 1. Okay.
You did +4.
Be thankful you don't have fat old man fingers like me. X cubed plus what is it? So I don't flip back a million times.
That's like a weird
The
accent.
X on the top, it does that. For
Oh, yeah. What is that? Interesting.
Makes it like
X. There we go. All right. Negative 0.716 or 0.717. I'm so happy that I have written this in so I have no room to put it in here. 177. I'm going to put 176. I like truncating better for this kind of stuff. And then we just fill in our 1 for x1. Okay, that's all. Just take the derivative at a point with your calculator. These last two, any questions on that before we move on? All right, these last two, basically the idea is that if we don't know, if we don't know all the in-between points, we just have to do our best. That's really all that these tell us. And this word, everybody underline differentiable. Our next lesson is all about differentiability. Basically, it just means that the graph is continuous and smooth. So we don't have any jumps, we don't have any holes, and we don't have any what we call cusps or corners. So our graph doesn't do something like this. Okay? This point right there would be non-differentiable at that corner. So it means think of a smooth curve, even a straight line, but just not something with either a discontinuity or a corner or cusp. So it's telling us this function is that, even though we don't have all the values. So what it says, find f prime of 3. What do you think the best choice would be for that? We're definitely going to put our approximately symbol here. What's the best choice for this one? Well, we don't really need it. Well, it's going to be to take the slope around that point, which is just 4 and 2. That's as close as we can get. Okay. So 10 minus 3 over 4 minus 2, which is 7 halves. So it's approximately the derivative there. Because we have limited data, this is as good as it gets. So the note here would be pick points as close around the requested value as you can. Okay, look down here. We're going to do that same thing again. W prime of 100. Please pay attention to this one because this kind of stuff is what bites you if you don't. 100 is in between here, so we know we're going to do 500 and minus 700 over 120 minus 80. Negative 200 over 40, which is what? Negative 5. Now, labeling is what I want you to pay attention to. And we have 30 seconds or so. What are we going to label this negative 5? It is W prime, so first of all, it's a rate, which means there's a per in there, but there already was a per in W. Do you see that? This is already a rate. So this is going to be gallons per second. Okay? Which we typically write, I don't need equals there. We're going to write, this is the same as acceleration in physics. We'll say gallons per second squared. I should write seconds there. Second squared. Okay? So be careful. If you're taking a rate and taking the derivative, now you're per. Meaning we're picking up this every second. The rate is growing. So we can come back to that one tomorrow just to reiterate that. Let's do the odds plus test prep on this one, please. And in the test prep, do all of them. Do you want to come and ask me about that? Odds plus test prep.